All right, welcome back, everyone. Today we're going to talk about subtracting real numbers. In this section, you're going to learn how to subtract real numbers, how to evaluate algebraic expressions with real numbers using addition and subtraction now, and how to determine if a number is a solution to a given equation. So it's important to remember that addition and subtraction are essentially the same operation. Right? Subtracting a number is the same as adding the opposite of that number. Okay, so if we have a minus b, we can just as easily say that's a plus negative b. And remember from the previous section that if we have the opposite of a number, so two negatives in a row, a minus negative b, then that's just going to become positive. And these are going to be our rules for subtracting real numbers. So now we just want to subtract these numbers. Well, if we see a minus sign, we can rewrite that minus sign as plus negative 4, because there's only one. Now we have two numbers with the same sign, and so we can add the numbers. 13 plus 4 is 17, and keep the sign. And so it's negative 17. On part B, we have 5 minus negative 6. Now we have the opposite of a number, 5 minus negative 6. Those two minus signs will essentially become a plus sign. And 5 plus 6 is just 11. Next, we have 3 minus 6. Because it's only one minus, we can rewrite this as 3 plus negative 6. They have opposite signs, so we subtract the numbers. 6 minus 3 is 3, and we keep the sign of the one with the biggest absolute value, or in this case, negative 6. And finally, negative 1 minus negative 7. Well, again, we have two negatives in a row, the opposite of a number. So what we get is negative 1 plus 7. Now they both have different signs, so we subtract the numbers. 7 minus 1 is 6. And we keep the sign of the bigger number, which in this case is 7. So we're going to continue to use these ideas, but now we're going to expand them into slightly larger problems. And so let's start with first negative 14. Now we have minus 8. And so minus 8 we can rewrite as plus negative 8 plus 10. And now we have minus negative 6 because we have two minuses in a row. We can make that plus positive 6. So now let's just finish the problem. Negative 14 plus negative 8. They have the same sign. 14 plus 8 is 22. And so add the numbers and keep the sign. 10 plus 6 is just 16. A negative 22 and 16 have opposite signs, so we're going to subtract the numbers. 22 minus 16 is 6. And we're going to keep the sign of the one with the biggest absolute value. We do the same thing for the next example. Negative 20. Now we have minus 5, so we can make that plus negative 5, plus 12. And then minus negative 3, which is going to become plus 3. Once again, we can add the first two numbers. They're both negative. 20 plus 5 is 25. And we keep the sign. 12 plus 3 is 15. And negative 25 plus 15, they have opposite signs, so we subtract the numbers. 25 minus 15 is 10. And we keep the sign of the one with the biggest absolute value. And so the answer is negative 10. So as before, to evaluate algebraic expressions, we just want to plug in the numbers that you're given. Okay, but remember now we're dealing with adding and subtracting real numbers, and we have to remember the order of operations. So we want to find the value of these expressions when x equals 2 and y equals negative 5. So we have, for the first one, x minus y is equal to 12 plus x. So let's just take out the variables. We're going to replace them with parentheses. And then we're going to plug in our numbers. So x is 2, and y is negative 5. So it's easy to see here on the bottom, we just have 14, 12 plus 2. And now on the top, we have 2 minus negative 5. Well, minus negative 5, that's the opposite of the opposite, what we talked about in the last section, and the beginning of this one, and it's just going to make that a plus sign. And so now we get 2 plus 5, which is just 7. And we can reduce this fraction. They're both divisible by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. And so the answer would just be 1/2. Do a similar thing for part B. We're just going to replace the letters with parentheses. Right now we have x squared minus y. X is 2, y is negative 5. 2 squared is 4. Now minus negative 5, once again, 2 minus signs, that's going to become a plus. And 4 plus 5 is just 9. So once again, remember from section 1.3, to determine if a number is a solution to an equation, we just want to plug the number in and see if both sides are equal to each other. If they're equal, then it's a solution. If they're not equal, then it's not a solution. Okay, so the only difference now is we're using positive and negative numbers. So we want to determine whether negative 4 is a solution to this equation. X minus 5 equals negative 9. So x minus 5 equals negative 9. Once again, we're just going to replace x with the value of negative 4. And so negative 4 minus 5, this is the same thing as saying negative 4 plus negative 5, because there's only one minus sign. Negative 4 plus negative 5 is equal to negative 9. The other side's negative 9. And so, yes, this one's a solution. We want to do the same thing for the second example. We have negative 1 plus x is equal to 1. We're just going to replace x with a parentheses and then plug in negative 2. Now, negative 1 plus negative 2, they have the same sign. So we're going to add the numbers. 1 plus 2 is 3. Keep the sign. And now negative 3 is not equal to 1. And so negative 2 is not a solution of that equation. So at the end of this lesson, you should be able to subtract real numbers, evaluate algebraic expressions, and determine if given values are solutions to equations.